In this video, I'm going to have a look at how we can go about graphing quadratics when they're given to us in the general form of y equals ax squared plus bx plus c. Now, to begin with, I want to sketch just a basic quadratic of this format and go through what we already know. So if we've got our quadratic here and it's been given to us in general form, we know from back when we did the discriminant as well as the quadratic formula that the roots themselves can be found by doing negative b plus the square root of the discriminant divided by 2a for the right hand one, and then negative b minus the square root of the discriminant over 2a for the left hand root. We also know that the y-intercept, when it's in general form, is simply the value of c, because it's when x is equal to 0. We also know through quadratics that they're symmetrical with each other. So if we did this vertical line here at the vertex, we're going to have a symmetrical graph on the left and the right hand side of this. And we call this line of symmetry the axis of symmetry. And the axis of symmetry is the x-coordinate in essence of the vertex. So the same sort of thing. So if we can go about finding what the axis of symmetry is, we actually find what the x-coordinate of our vertex is within this graph, which is useful for us when we go to sketching it. Now, to find this axis of symmetry, we can use the properties of symmetry to find where this point is existing along this line. And to find the midpoint between these two roots, we essentially add them together and divide by 2. Now, when we do that, what that essentially does is cancel out this plus the square root of the discriminant and subtract the square root of the discriminant. So the axis of symmetry is equal to negative b divided by 2a. Now this here essentially is the important information that we need when we want to sketch the quadratics if they're given to us in general form. So now let's have a look at how we go about doing it. So let's now say that we want to sketch the graph using the vertex and axes intercepts of the following quadratic here, the y equals 2x squared plus 8x minus 10. Well, what I want to start by doing is, first of all, let's find this vertex. And to find the vertex, I first of all need to find the axis of symmetry. Now, that occurs at negative b over 2a, which happens to be our x-coordinate of the vertex. So the negative of b is going to be negative 8 divided by 2 times our a of 2, which negative 8 divided by 4 will be negative 2. So what we now know is the x-coordinate of our vertex is negative 2. So to find the y, we want to look for it when our x is equal to negative 2. So substitute negative 2 back into this. So our y is equal to 2 times negative 2 all squared plus 8 times negative 2, take 10. So simplifying this, 2 times 4 will be 8, take 16, take 10, negative 8, negative 18. So our vertex occurs at negative 2 and negative 18. So now I've found my vertex, what I want to do is find my y-intercept. And my y-intercept's nice and easy. It's where my constant is, so it's at negative 10 here. Then the next thing you want to go about finding is the roots of the quadratic, so the x-intercepts. Now the x-intercepts occur when y equals 0. Now there's a few ways that you can go about doing this. You can use the quadratic formula, or you can see whether you can factorize it. My advice is to generally start by seeing whether you can factorize it easily, and if you're spending a little bit too long or can't think of what the factorization roots are, then just go to the quadratic formula because it's going to be quicker in the end to use that formula. Now in this case I can see that it's going to be factorized first of all by taking the highest common factor of 2 out. So this will leave me with x squared plus 4x take 5 is equal to 0. And then I'm looking for a sum of 4, product of negative 5, which will be x plus 5, x take 1. So therefore my x, or my roots, are going to be equal to -5 or +1. And hence our x-intercepts are these. So at this point, what we've essentially found is the axis of symmetry, which we've used to find the vertex. We've then found the y-intercept. We've then let y equal 0, so we could find the x-intercept. In this case, I used factorization to find it. Keep in mind, if I couldn't factorize it easily, I would have gone with the quadratic formula instead. But I've found where it cuts the x-axis. So now all that's left to do is to put this information onto a graph and sketch my graph. So as you can see here, I've included the vertex, the y-intercept, and our 2 x-intercepts on my sketch of the quadratic just here. So in summary, when you're sketching the quadratics, when they're in general form, you in essence want to start by finding the axis of symmetry and use the axis of symmetry, which is the x-coordinate of our vertex, to find the y-coordinate of our vertex, and hence the whole vertex. Then you know what the y-intercept is because it's just our value of c, but you want to use either factorizing or solving quadratics in some manner when y is equal to 0 to find our x-intercepts. Once you've got all that information, you then put that information on the graph and sketch it, as I've done here.